Good afternoon, teachers. Good afternoon, grade 12 learners. I know this is a very crucial time for you. We're preparing for the final examinations, and today is the 13th, and we know very well that on the 31st of October, we'll be sitting down for the mathematics paper 1 final examination, and then on the 3rd of November, we'll be sitting down for mathematics paper 2. So let me take this opportunity to wish you well in your exams, grade 12 learners. I wish you all the best, and I think this is the time that we should now start practicing a lot. We have learned lots and lots of aspects. We have been taught lots and lots of aspects. So it is time for us now as grade 12 learners to practicing. And basically today, I'm going to take you through a revision program. We're going to practice a bit on statistics. My name is Mohapi, subject advisor for mathematics in Motao District. Like I indicated, I believe I'm going to focus on statistics. The question is, on statistics, what is it that we are going to focus on? Thank you. Let's work together. We have to deal with various aspects in statistics. Number one, I'm going to focus on the 5-number summary. 5-number summary. So the question is, if we talk of the 5-number summary, what are we referring to? You remember when you are given a set of data. When you are given a set of data, you must then be able to identify, number one, the lowest value. The lowest value, which we call the minimum value. And that constitutes the first number of the 5-number summary. We've got Q1, quartile 1, which we call the lower quartile. We've got quartile 2, Q2, which we call the median. We have quartile 3, which we call the upper quartile. And we also, lastly, we've got the 5th number, we've got the maximum value. That is the maximum value. These numbers, the minimum value, maximum value, Q1, Q2, and Q3, they constitute what we call the 5-number summary. And this 5-number summary will enable us to draw what we call a box and whisker diagram. Box and whisker diagram. This diagram is a way of representing learners' performances or representing data graphically. Can represent data graphically with the aid of box and whisker diagram. As the name indicates, box and whisker. If I were to illustrate quickly, we've got a box. Here is a box. And then we also need to indicate the whiskers. The whiskers, that will be the maximum value. The whiskers, this will be the minimum value. So in terms of indicating the 5-number summary in the box and whisker diagram. Here I said you write down. Remember, what is key is that you take your ruler. You've got a number system. So this number here, they must correspond properly. Say it's 2. I'm just making examples. It's 5. It's 9. It's 13. Just making an example. So this number, it must correspond with that one. This, let me show you the numbers. 2 here. This 2 must correspond with that. So normally this is what we call a minimum value. The lowest value, we indicate it here. The highest value, which we call the maximum value, is this one. Now here we've got quartile 1. In here we've got Q3. This is the upper quartile. This is the lower quartile. Somewhere there we have what we call quartile 2, which we call the median. Say the number here can be 7. I'm just making a rough diagram. So this will constitute what we call a box and whisker diagram. So in the box and whisker diagram, we must indicate 5 numbers. Minimum value, upper quartile, lower quartile, median, and the maximum value. Let me repeat. A minimum value, quartile 1, which we call the lower quartile, quartile 2, which we call the median, quartile 3, which we call the upper quartile, and lastly, the maximum value. Those 5 numbers, we can then draw a box here. That box has got whiskers on both ends. So here we've got the maximum value, here we've got the minimum value. And whatever numbers that you say there, firstly, you must draw up a number line. and then you calibrate it correctly. And we use a ruler to calibrate the number line. So this is what we call the 5-number summary. Just a brief revision. A brief revision, because I want to give you some exercise to refresh your mind on 5-number summary. Remember, if you talk of statistics as a topic, stats as a topic, it constitutes about 20 marks of 150 marks of paper 2. Meaning, on the 3rd of July, and the 3rd of November, you'll be sitting for mathematics paper 2. The paper will be written out of 150. 20 marks will be from statistics. And that is the focus for this session. For now, I'll be focusing mainly on those 20 marks. I've talked of the 5-number summary and the box and whisker diagram. Definitely, there'll be a question around the box and whisker diagram. And there is no way we can talk of the box and whisker diagram and leave out the 5-number summary. The two goes hand in hand. Thank you. What else can we expect in this coming June examination? You know the mean, you know the mode, you know the interquartile range, Those are some of the terminology that I know you are familiar with, and that we possibly can come across on the 3rd of November. A mean. Remember, how do we calculate the mean? You add all the scores and divide by the number of scores. To determine the mean, you add all the scores. After adding all the scores, you divide by the number of scores. Then you'll get what you call the mean. Check the mode. The score that appears more often than any other score is a mode. Mode is a score that appears more often than any other score. Interquartile range. Remember earlier on in the 5-number summary, we talked of upper quartile and the lower quartile. So remember, we have what we call the range, which is given by highest value minus lowest value. I repeat, range in a data, highest value minus the lowest value. So if you talk of the interquartile range, this one is Q3, quartile 3 minus Q1. That is how we determine interquartile range. Mode is the score that appears more often than any other score. Mean, how do you get the mean? You add all the scores, you divide by the number of scores. Then you get what you call the mean. I'm just taking you through this stuff so that when I give you an exercise, at least your mind is a bit refreshed. Now, I'm going to do some activity together with you. Let's see how far can we go with that activity. Here is an activity, thank you, that I want you to do. Thank you. 15 members of the basketball. I hope you can see it clearly. It's written, 15 members of a basketball team took part in a tournament. All in all, there were 15 members of the basketball team took part in a tournament. Each player was allowed the same amount of time on the court. The points scored by each player at the end of the tournament are shown below. Those are the points scored by each player at the tournament. The points scored by each player at the tournament. Remember, we have 15 players. The first player, 27, scored 27. The second player, 28, 30, 32, 34, 38, 41, 42, 43, 43, 44, 46, 53, 56, 62. You've got the data. And fortunately enough, this data is already arranged in ascending order. Ascending order, it means you start with the lowest value and end with the highest value. So we've got 15. They are all the scores there. All in all 15. We can count them, verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Those are the scores of the 15 members of a basketball team that they scored in a tournament. The points scored by each player at the end of the tournament are shown below in the basketball team. Thank you. We have analyzed the question. We know what is given. The first question: determine the median of the data. Determine the median of the data. The first question is, what is a median? Terminology is very much important in statistics. A median is the score that is in the middle. Here we've got 15 members of the basketball. This is their scores. So the question states, what is the median of this given data? The median, we define median as the score, the middle score. It means you check on the left-hand side, you check on the right-hand side. The score that lies in the middle is the one that we call the median. And for you to identify a median, firstly, it means the data, your scores, must be arranged either in ascending or descending order. You start with the lowest and end with the highest, or start with the highest and end with the lowest. But it is recommended that every time, let's write in ascending order. Start with the lowest number and then end with the largest number. The median is the score that is in the middle. So you've got the scores there. Already, the scores are arranged in ascending order. You start 27, 28, 30, 32. They are increasing: 41, 42, 43, 43, 46, 53, 56, 62. They are increasing. So the first question is, determine the median of this given data. I'm not going to do it for you. I want you to work it out for yourself. Please, learners, remember, this is the time for practice. So I'm just going to give you a minute. I'm going to be silent for a minute. And then after a minute, I'll take you through the solution of that problem. But for now, you need to calculate for me the median of that data. Thank you. Welcome, welcome, welcome. So this is how we determine the median now. You check your answer against mine. I said sometimes the scores might not necessarily be arranged in ascending order. So for you to determine the median, task number one, ensure that the scores or the data is arranged in ascending order. By ascending order, we mean you start with the lowest number and end with the largest number. So fortunate enough, in this case, the scores of the data is already arranged in ascending order. So to determine the median, the middle score, check. We have 15 here, 15 members. So it means there must be 7 from the left and 7 from the right. So the middle score will give you the median. Check. It's 1, 2, 3, 4, 5, 6, 7. This is 7 from the left. If I start from this side, this is score number 7. Start from the right. 1, 2, 3, 4, 5, 6, 7. This is 7. So it means this 42 is in the middle. Is in the middle. That 42 is in the middle. So the median, to answer 1.1, we say median is equals to 42. What is a median? The score that lies in the middle. There are 15 sets of data, 7 from the right, 7 on the left. So data number 8 is in the middle. 42 is our median. Thank you. I hope you got it right. I can see some of you are becoming a bit happier. Thank you. That's great. That really shows you do remember. But for those who did not get it right, let me repeat it. To determine the median, ensure that the scores are arranged in ascending order, and then you look for the middle score. By middle, it means, like for instance, in this case, here is 42. On the left-hand side of 42, there are 7 scores. On the right-hand side, there are 7 scores. So 42 is in the middle. So 42 is called the median. Are you okay? Thank you. Let's check the second question. Determine the interquartile range. The interquartile range. I gave you the formula. And I said range, if you talk of the range is the highest score minus lowest score. That is range. Range is highest score minus lowest score. If I've got to show you that again, quickly. Earlier on, I talked about those values, the mean, the mode, the interquartile range. And I said range is the highest value minus lowest value, or highest score minus lowest score. Interquartile range, upper quartile minus lower quartile. Q3 minus Q1. Thank you. Now you've got the answer to this one then. 1.2, determine the interquartile range. 1.2, we need to determine interquartile range. And if you still remember, I said the interquartile range is equals to quartile 3 minus quartile 1. So the task now, our task is to determine Q3 and then to also determine Q1. Once you've got Q3 and Q1, it's easy for you to determine the interquartile range. Thank you. I'm going to give you again a 2 minutes. This time for 2 minutes, you determine Q3, you determine Q1, and then determine the difference between the two, because the difference between Q3 and Q1 will then give you the interquartile range. This is about practice. Teachers, please, let's exercise this every time we are with our learners. Give them the chance to practice. Give them exercises to do. They must do lots and lots of exercises. So for 2 minutes, carry on with that one then. Remember here, the question states determine the interquartile range of the data. Determine the interquartile range of the data. And the formula is interquartile range is equals to upper quartile minus lower quartile. So I said our task is to identify Q3. We've got our data arranged in ascending order. It's fine. Here is our median. Our median is 42. Let's hide the median. Let's hide the median. Hide the median. Thank you. The median is hidden now. Now, how many scores do we have now? We've got 1, 2, 3, 4, 5, 6, 7. You hide the median, and then on the left-hand side of the median, you've got 7 scores. Let's check the median of the 7 scores. I think it will be number 4, because it will be 1, 2, 3. This will then represent the median of the lower value. And the median of the lower half is called Q1. The median of the lower half is called Q1 because we've got 1, 2, 3. We've got 1, 2, 3. This one is the median. Median of the lower half represent Q1. So it therefore means Q1, this one, Q1, let me write it down. Q1 is equals to 32. That is the lower quartile. Let's look at the upper quartile. Just like we did earlier, hide all the scores until the median. Our median is 42. Hide those scores. Scores are hidden. Now, from the right, let's check the median of the upper scores. Remember, the median of the upper scores will then represent upper quartile. How many scores do we have? 1, 2, 3, 4, 5, 6, 7. 7 scores. So it means the fourth one will be the median. You'll be having 1, 2, 3. It means this one will then represent 46, will then represent the median of the upper half, which you call the upper quartile. Therefore, Q3 will then be equals to 46. See, you've got 46, you've got 1, 2, 3, 1, 2, 3. To determine Q1, hide all the numbers, including the median. And then check in the lower half, check the middle score. To determine Q3, hide all the scores like we did, including the median. Now on the upper half, this one will then be left displayed. And then you'll check the median of those two. That will then represent Q3. So our Q3 is 46. So the question states, I hope you can still see the question. Determine the interquartile range of the data. So we said interquartile range is equal to Q3 minus Q1. Let's check Q3. It's 46 minus 32. And then the answer is 46 minus 32. Simply subtract 46 minus 32. You'll end up with 14. So this is the interquartile range. It's easy. Just determine the difference between Q3 and Q1. It is key, it is very much important for you as learners to be able to identify Q3 and Q1. So you've seen how we identified it. That's how to identify Q3 and Q1 respectively. The next question. Draw a box and whisker diagram to represent the data. The next question. Draw a box and whisker diagram to represent the data. Draw box and whisker diagram to represent the data. Is 1.3. Remember, for you to draw a box and whisker diagram to represent this data, firstly, you must identify the 5-number summary. Firstly, you must identify the 5-number summary. Let's go together. Remember, the 5-number summary, the first one I said, the minimum value. Minimum value, in this case, look at the scores, 27, 28, so the minimum will then be 27. Let's go to Q1, quartile 1. Remember Q1, we said it's 32. Let's look at Q2, which we call the median. Q2 is what we call the median. So check the data. This is Q1, Q2, Q3. So our Q1 here is 32. Q1 is 32. Q2 is 42. And then Q3. Q3 is equals to 46. And then the maximum value, will then be, let's check the data. Our maximum value is 62. Maximum value is 62. Thank you. I've given you the 5-number summary, the minimum value, Q1, Q2, Q3, maximum value. So our task now is to draw a box and whisker diagram. Box and whisker diagram. And we make sure that we indicate all those values. Let's check them. Box and whisker diagram. Firstly, draw your number line. This is important. Step number 1, we must first draw our number line neatly with the aid of a ruler. Thank you. We've got a number line there. And then you start calibrating. And in your calibration, ensure that these numbers are there. It's up to us which multiple do we choose. Can go with the multiple of 3 and see how far do we go. Let's check. Let's say we've got, start from negative infinity, go to 27. Let's use the ruler. If you go with the multiple of 3, we'll go up until 10 maybe. 10 is here. Let's go up until 20. Thank you. Let's take the multiple of 4 then. Okay. 1, 2, 3. Nicely. You need to relax and calibrate your numbers. Calibrate your numbers. Let's check. We've got 27. Let's say plus 4. We've got 31. Plus 4. We've got 35. Plus 4, you've got 39. Plus 4, you've got 43. Plus 4, you've got 43. Plus 4 is going to give you 47. Plus 4, you've got 51. Plus 4, you've got 55. If we add 4 again to 55, you've got 59. And then after adding 59, then you'll have 63. So here is our number line. Start from 27 up to 63. So if you say minus 4 here, you can still go up to 24. It's a number line. So let's indicate the values. The first one is the minimum value. Here is the minimum value. 27. Directly above 27. With the aid of a ruler, directly above 27. The maximum value, let's check. Q1, 32. Just next to 31, somewhere here, we've got 32. So directly there. That will then be Q1. 31 just next to 32. Directly above 32. It's Q1. This is our 32. Let's check our median then. Our median is 42. We've got 43 here. Just next to 43, we've got 42. This will be our median. Remember, this is also a minimum. This is our Q1. Now we've got Q2 as 42. Let's determine Q3. It's 46. Just before you reach 47, you've got 46. Just on top is Q3. Q3. This one is called Q3. And then the maximum number. According to our maximum number is 62. Just next to 63, there you've got 62. And then just exactly on top, that is 62. Now we draw a box and whisker diagram. Remember, minimum, the box, maximum, that box, and then we draw that box here. With the aid of a ruler neatly, let's draw the box. And then remember the whiskers now, the whiskers. Let's indicate the whiskers. These are our whiskers. This is the maximum. This is the minimum. This is Q1. This is Q2. Let's indicate Q2. Q2 is 42. Here is 42. Thank you. There we are now. Now we have represented that data. We have drawn the box and whisker diagram that represent the data. The minimum is 27. Q1 is 32. Q2, our median is 42. Q3 is 46. And then the maximum 62. This is the box and whisker diagram that we requested to draw. I hope this is a session that is not difficult really. And should it happen that we come across a question that requires us to draw a box and whisker diagram in the examination, we need to make sure that we collect the marks. We need to make sure that we get all those marks. This is an easy stuff. Identifying minimum value, quartile 1, Q2, Q3, and maximum value, and then drawing box and whisker diagram. That is an easy stuff. And this is where I always say learners need to score marks. We need to make sure that we don't make mistakes here. We need to make sure that we score the marks. Thank you. I think this question we have covered it. We are able to go up to there, draw a box and whisker diagram for the data. I hope learners, we are together. And I hope even the diagram that you have drawn is very much similar to this one. And I hope that you also understood me very well on how I drew this box and whisker diagram. It is important that these values, 27, 32, 42, 46, and 62, must be indicated on the diagram. Remember, it's minimum, Q1, Q2, Q3, and maximum value. They must be clearly indicated on the diagram. So ultimately, you'll end up with the box and whisker diagram looking like that. I hope we're all happy. Can I go to the next question? Let's go to the next question. Here is the next question. Thank you. Thank you. There we are. There we are now. Let me take you through, just 3 marks, let me take you through the question. It reads, the scores for 8 golfers who played a single round of golf on the same golf course are shown below. The scores of 8 golfers. The scores of the 8 golfers is shown. Let me try and indicate that clearly. Here we are. The scores of 8 golfers. How many golfers are there? All in all, there are 8. 1, 2, 3, 4, 5, 6, 7, 8. Those are their scores. The first question. calculate the mean score. Calculate the mean score. Remember how to calculate the mean. I said to you, to determine the mean, you add all the scores, divide by the number of scores. Add all the scores, divide by the number of scores. For a minute, calculate the mean. I'm going to give you a minute, and immediately after a minute, you'll check your work against mine. Carry on. Calculate the mean of the score. Thank you. Welcome. Let's check how you calculate the mean. Remember the mean? See, this is how you calculate the mean. 2.1. Mean is equals to, you add all the scores. 69 plus 71 plus 75 plus 74 plus 78 plus 70 plus 72 plus 71. All the scores. 1, 2, 3, 4, 5, 6, 7, 8. 8 scores. 1, 2, 3, 4, 5, 6, 7, 8. 8 scores. And then you divide the number of scores. Let's divide. This is all over 8. All over 8. And it is important. You cannot enter the examination room without the calculator. That's why today I brought my own calculator here. Because I knew very well that I'm going to deal with you statistics. And for us to solve problems related to stats, we just need a calculator. Thank you. Let me add them all together. 69 plus 71 plus 75 plus 74 plus 78 plus 70 plus 72 plus 71. So all in all, this course, they give us 580. Got 580, we divide by 8. Let's divide 580, divide by 8, and then you've got our 72,5. This is our mean. How do you calculate the mean? Add all the scores, divide by the number of scores. That is the mean. Let's check the next question. Calculate the standard deviation of the data. 2.2. Calculate the standard deviation of the data. I know probably you've forgotten the calculator usage. Remember, we always say, number one, I think everything can be clearly displayed. If you want to calculate the standard deviation mode, then you go to number 2, which is statistics. And then we go to standard deviation, number 1, variance. Let's enter the scores. Let's enter the scores. It's 69, 71, 75, 74, 78, 70, 72, and 71. All the scores has been entered now. Now remember, you just have to press AC, go to Shift, and then 1. Then you have to choose what is it that you need. Let's go to number 4. Number 4 there, you've got, it gives you those options. The mean, standard deviation. So if you check number 3 is our the standard deviation, then you enter 3, then equals to, therefore our standard deviation here is equals to 2.78. Standard deviation here is 2, let me write it down. Standard deviation is equals to 2.78, correct to 2 decimal places. Correct to 2 decimal places. We always encourage learners to just use a calculator and determine the standard deviation. Teachers, let's take our learners through that exercise. Our learners must be able to calculate the standard deviation. Here, I used a calculator to determine the standard deviation. Please, practice, and practice makes everything be easy, and then you become perfect. And those procedures, the procedures that we use for calculating standard deviation, learners, if you practice, everything will just come so easy for you. You always play around with cell phones, and you master them so much. So calculators can be difficult. That is how we used standard deviation to calculate, how we use the calculator to calculate standard deviation. Sometimes to calculate standard deviation, we can use a formula. In case you have forgotten the procedure, we say standard deviation is equals to sum of all squared deviation all over n, the square root of all that. Then that will give you the standard deviation. If we have to go through all those long way, deviation from the mean, we have the mean, how much does each score differ from the mean, add all those deviations and then divide by n, determine the square root thereof, you'll end up with the standard deviation. And the answer I got here and the answer you get when using this formula, those answers will still be the same. Thank you. Let's check the last question. How many golfers' score lie outside one standard deviation of the mean? How many golfers' scores lies outside one standard deviation from the mean? Thank you. Very much important. Remember, we've got the mean there. Our mean is 72.5. Standard deviation is 2.78. So to determine the scores, how many of the scores lies outside one standard deviation? Let's check the difference between the two. Remember the coordinates. I always prefer this coordinate to say mean minus standard deviation and mean plus standard deviation, one standard deviation. Those are the coordinates that I normally use. And then remember our mean, let me take you back, 72.5. This was our mean. So you've got 72.5 minus standard deviation is 2.78. Second coordinate, mean 72.5 plus standard deviation is 2.78. Let's check the coordinates. Remember here we are now answering 2.3. Maybe I should number it correctly because numbering is key. Mean minus standard deviation, mean plus standard deviation. Let's check the difference. 72.5 minus 2.78. I think there we've got the answer that we get is 69.72. 69.72. Let's check 72.5 plus 2.78. Let's check the answer that we get. The answer is 75.28. Thank you. We have this score and this score. So the question is, how many? What is the question? How many of the golfers' scores lie outside one standard deviation of the mean? We're going to look to all the values that lies outside this. Remember, we've got our scores must be between 69 and 75. Let's check how many lies outside 69 and 75. Check 69. It is inside. 71. It is somewhere between 75. It's in. 75. Still inside because we've got 75.8 here. If I were to show you these numbers. Thank you. The question is how many golfers' scores lie outside one standard deviation of the mean? We're trying to count. 69. It's inside. We want to check all the values that lie outside this. Remember, on the number line, if you draw a number line, you've got 69 here, then somewhere you've got 69.72, and then you've got 75.28. We want all these values that are here, all the values that are here, that are outside this boundary. So check 69. Is 69 in this boundary? It's out. So this is the first score. Let's check 71. 71 is somewhere in between. It's inside. 71 is inside. 75, it's inside because 75 is somewhere here. Before you reach 75.28, you've got 75. It's inside. 74, it's inside. 78, this one is outside. This is the second. 78 is outside. 70, it's inside. 72 is inside. 71 is inside. So how many of the scores? It means 2 of the scores. How many scores lie outside one standard deviation of the mean? So how many? Only 2 scores lie outside. The rest lie inside 1 standard deviation of the mean. Thank you very much. I think we have had a very interesting session. I want to give you a 5 minutes break, and then after 5 minutes, we carry on with our session. We'll be focusing mainly on scatter plots and regression lines. For now, you can have 5 minutes break, and you'll join me again after 5 minutes. Thank you. Welcome teachers, welcome learners. Let me take this opportunity again to take you through the scatter plots, because I think I've already taken you through the first session of statistics. So for now, I'll be mainly focusing on the scatter plots. So $1 million question is, what is a scatter plot? Basically, a scatter plot is a diagram. It's a diagram which we use to compare two sets of data. Scatter plots, it's a diagram which we use to compare two sets of data. You've got one data, you've got the first set of data, you've got the second set of data. So you want to compare, and you also want to establish whether there is a relationship between the two sets of data. So we use a scatter plot. It's a diagram that we use to compare two sets of data, to determine whether there is a relationship between the two sets of data or not. Thank you. Let me make an example of the scatter plot. Let me take you through the first example. This is a scatter plot. This is a scatter plot. Then, slowly, let me take you through this exercise. Let's read the statement. A group of 8 learners. So now we are talking about 8 learners now. A group of 8 learners was randomly selected from a class. A group of 8 learners was randomly selected from a class. The performance of these learners in a standardized test, which counted 150 marks, and the average number of hours they spent watching TV each week was recorded. You see, we've got two sets of data. The test scores for the learners and the average number of hours that the learners spent on watching TV. So we are going to compare, we are going to establish whether there is a relationship between the two sets of data. The first set of data, scores obtained by the learners. Second set of data, the hours, the number of hours these learners spent watching TV. That's how we set a scatter plot. We use the diagram. You can see we've got a diagram there. We use that diagram to compare or to try and establish whether there is a relationship between the two sets of data. So in this case, we've got eight group of learners. The performance of these learners in a standardized test and the average number of hours they spent watching TV each week was recorded. The data is represented in the scatter plot below. Let's check the scatter plot. The test scores obtained, here we've got test scores. It was out of 150. 10, 20, 30, 40. These are the scores obtained by learners. Test scores. Here, the x-axis, or the horizontal axis, the average number of hours spent watching TV. Depends how many hours do the first learner spend on watching TV. Let's say, for instance, check this one. The scatter plot. Scatter plot is basically the dots. Check this point. This is the point I'm talking about. I hope you can see it. According to this point, it's 5 here. Number of hours spent on TVs were 5. The marks obtained, it's 120 here. Somewhere between 120, it's going to be 125, somewhere around 127, 128. 128 marks out of 150. Check another learner. Here's the next learner. How many hours here? Remember, it's 10, 15. Between 10 and 15, right in the middle, it will be 12,5. So here is 12. See, it's 12 here. Number of hours is 12. How many marks did this learner score? Just below 120, it will be 100, somewhere randomly, almost 118. We're just estimating. Let's check this other learner here. Spent 45 hours. spent watching TV. Let's check the score. The score, 45, here is the point, 30. This learner obtained 30 out of 150. The learner spent 45 hours watching TV. This learner obtained 30 out of 150. This learner spent 5 hours watching TVs. This learner obtained 128. Thank you. This is a scatter plot. Like I indicated earlier, a scatter plot is a diagram which enables researchers to compare two sets of data to determine whether there is a relationship between them. You compare two sets of data and try to establish whether there is a relationship between them. Like now, is there a relationship between test scores obtained by learners and the number of hours they spend watching TV? Is there a relationship? This is a question. Let me take you through some questions there. The first question: what is the lowest score for this group of learners? The lowest score. Remember I said we've got 8 learners. Point number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. The lowest score. To answer this one, you just look here. This is the lowest score. It means the lowest score here is 3.1. Lowest score. 3.1. Lowest score here is equals to 30. How do we see that? Remember, we've got 8 learners. The score here is 130. It's 130. The score here is almost 128. The score here is almost 127. The score here is between 100 and between 90 and 100, around 95. The score here is 89 or 90. Check this one score. Just above 70. It can be 71, 72. The score here, just below 50, it can be 48, 49. This one is on top, is 30. So this is the lowest score, because we talk about 8 learners. 1, 2, 3, 4, 5, 6, 7, 8. The lowest score here is 30. The first question answered. And I hope, learners, you are happy with the answer that I have got. Let's check the second question. Does the data display a linear, quadratic, or exponential relationship? Halala. Interesting question. Does this data represent linear, quadratic, or exponential relationship? Justify your answer. Justify your choice. Now we look at the scores. How best can we join the scores? If you try to join the points here, I think more or less they form a straight line. They are not exactly in a straight line, but the best way of representing all the lines will be through a straight line. And so if you talk of a straight line, then it will be a linear function. So does this data display linear, quadratic, or exponential? 3.2 will then say it represents linear. Because if you look at these lines, the points they lie in a straight line. It's a straight line with a negative gradient. And a straight line with a negative gradient implies an indirect proportionality. In a way, as the value of one set of scores increases, the other set decreases. If the value of the other variable increases, then the value of the other one decreases. There is indirect relationship. So in this case, it will be linear. Remember, a linear, we say, is a straight line. Straight line can be like this or like that. It's a straight line. If we talk of an exponential, quadratic is a parabolic. It can be like that. Let me show you the quadratic. This is a quadratic relationship or a quadratic relationship. Exponential, can it be exponential? Remember, exponential can be displayed. Check this one. There is an exponential growth. Or if it decreases, that can be the exponential growth. Let me draw a line here. The two, more or less, they represent exponential growth. This and this. Parabolic. This is a straight line. So if you look at this set of data, the more closer explanation will be straight line. That's why I said, does this data display a linear, quadratic, exponential relationship? The answer is linear. Why? Because the those points, they are closer to a line with a negative gradient. The next question, 3.3. What conclusion can be reached about the learner's test scores and the average number of hours they spend watching TV? You draw a conclusion. What conclusion can be reached about the learner's test scores? These are the test scores. And the average number of hours they spend watching TV. It's very much interesting. And I want you to try it. Before I can give you an answer, I want you to try it yourself. 3.3. What conclusion can be reached about the learner's test scores and the average number of hours they spend watching TV? I want you to take it head on. For a minute, jot down your own conclusion. Welcome. Thank you. Check your explanation against mine. Remember the question. What conclusion can be reached about learners' test scores and the average number of hours they spend watching TV? Based on this scatter plot, you can see, maybe if I should clarify, this one, the learner spent 5 hours watching TV. The learner obtained 128 marks. This one, the learner spent about 12 hours watching TV. The learner obtained 121. This one, 15 hours. The learner obtained 115. This one, the learner spent about 21 hours, 21 to 22 hours watching TV. The learner obtained 97, 98. This one, the learner spent about 43 hours watching TV, and the learner obtained 48. 45 hours, 30. So, based on the scatter plot, the information on the scatter plot, we can then draw the conclusion that the more hours the learner spend on TV, the lesser the marks. If you spend more hours watching TV, then chances are you will get less marks. You spend fewer hours watching TV, then you will score high marks. And this is really the true picture. That's how we always encourage our learners. This is the time for examination. Let us not spend more time with studying with your books. So, based on this scatter plot here, the conclusion that we can arrive at is that the more hours the learners spend watching TV, the lesser marks they will get. The fewer hours they spend watching TV, the more marks they will get. That was 3.3, the last one. Another learner from the class watched 35 hours of TV per week. 35 hours watching TV. What is 35? Here is 35. The learner spend 35 hours watching TV. Using the given information, predict his or her performance in the test. Predict his or her performance in the test. Remember, if you draw the line of the best fit here, we said more or less, this will be the picture that you get. Roughly, more or less, that will be the line of the best fit. If you know it's not, maybe it will be slightly higher. So, for you to, if the question says, if a learner from the class watched 35 hours of TV per week, use the given information to predict his or her performance in the test. So here is 35 hours. Let's check the performance. Thank you. Here is the line, and then you move. Once you reach the line, go straight to the y values. Let's check. 35. It will be almost around, somehow almost around 58 or 59. So answering this question, I say around, then I will score plus or minus around 58 out of 150. How did you get that? 35. Let's go to the line. We predict it can be around 60. Even in the examination, they will give you a range to say, let the accept answers between 58 and 62. It will depend, but this is how you get the answer. 35, you drew a line representing the data, and then that corresponds with which value on the left-hand side. Then that will definitely give you the correct answer. That's how we answered the questions on scatter plot on this question paper. This is still data handling. This is still data handling. Scatter plots. I hope you're happy. I hope this will help. I hope this will add value. Let me take you through another question again. Let me take you through another question again around scatter plots. Around scatter plots. Let's check. The question reads, the time taken in seconds to complete a task and the number of errors made on the task were recorded for a sample of 10 primary school learners. 10 primary school learners. The data is shown in the table below. Have the table. There's the table. If I were to make it clearer, we've got the table there. What does the table show? Thank you. The time taken in seconds to complete a task and the number of errors made on the task were recorded for a sample of 10 primary school learners. We've got two sets of data here. We've got two sets of data. By merely going through the statement, one could pick up that we've got two sets of data. And we want to establish the relationship between the two sets of data. Hence, we have to talk about a scatter plot. Because, as I explained earlier, a scatter plot is a diagram which enables us to compare two sets of data to determine whether there is a relationship between them or not. So already if you read through the statement, you can tell that there are two sets of data here. So we want to establish whether the relationship between whether the relationship exists between the two sets of data. Time taken and the errors made on the task. Thank you. Check. Time taken 23, 21, 19. If I were try to explain this, number of errors made, only 2, if you take 23 minutes. 4 minutes, 21. 5 minutes, 19. Okay, sorry. Number of errors are 5. It takes you about time taken to complete a task, 19 in seconds. Check here. Number of errors made, 3. Time taken, 22. And so forth. The first question then states, draw a scatter plot of this data on the grid. I did not provide you with the grid, but I will just show you how to go about in answering the question. Draw a scatter plot for the data on the grid. Thank you. If I were to indicate to you, more or less, this is the answer that we'll be looking for. The grid that will be provided is that one. So all you have to do is to indicate the points. Check the first one. Number of errors, time taken. So check. Number of errors, time taken is 23. You go to 23. Here is 23. 23. Time taken is 23. I hope you can all see this 23. Number of errors is 2. You've got 0, 1, 2. Then you go straight. This is the point. The second one, time taken is 21. You go to 21. Check where 21 is. Here is 21. 4. Why is 4? Here is 4. Straight that way. This is the point. 19. Go to 19. 5. 19 corresponds with 5. Here is 5. 19. This is the point. Just like indicating an ordered pair in the Cartesian plane. This is an easy task. Learners, grade 12 learners, this is an easy task. because all you have to do is just to indicate a point on the Cartesian plane. Check. 15 seconds. Where is 15? Here is 15. 15 goes with 7. Let's check 7. Here is 7. Here is that point. Just indicate the points on the Cartesian plane. Sorry, 15, 7. Here is the point. Just indicate the points on the Cartesian plane, and so forth. Once you have indicated those dots on the Cartesian plane, then we then say you have drawn what we call a scatter plot. You have drawn what we call a scatter plot. I hope it's clear with everyone. We have drawn what we call a scatter plot. All you have to do indicates the dots. By indicate the points, the 8 of dots on the Cartesian plane. The diagram sheet provided already is calibrated. Number of errors made, time taken in seconds. All that learners have to do is to indicate the dots. Just say these are the x values, that is the y value. So it's a point in a Cartesian plane and in an ordered pair. Just have to indicate the points on the Cartesian plane. Then you're done. I think the first one is clear. And I'm telling you right now, it's a possible question. Come the 3rd of November, we are going to come across this question. Make sure that, learners, you don't lose marks unnecessarily. Thank you. That was the first question. The next question states, what is the influence of more time taken to complete the task on the number of errors made? Very much similar to the one that we did earlier. Very much similar. Very much similar. Remember the scatter plot that that I indicated earlier. This one, if I were to come back. Check the last question. Remember? Not the last. What conclusion can be reached to 3.3? What conclusion can be reached about the last test scores and the average number of hours they spent? You establish the relationship between the two set of data. So, even in this case here, what is the influence of more time taken to complete a task on the number of errors made? Number of errors made, the task. Let me show you the scatter plot itself. Let me show you the scatter plot. Remember, this is the scatter plot. This is the scatter plot. And if you can, remember, if I can ask you a question, grade 12 learners, is this linear, exponential, or quadratic? More or less, looks more or less linear. And if you draw, number of below and above must be more or less the same. Line of the best fit. That is more or less the line of the best fit. How many points are above? 1, 2, 3, 4, 5. How many points below? 1, 2, 3, 4, 5. More or less, that is the line of the best fit. So it's linear. So the first question then states, no, not the second. What is the influence of more time taken to complete the task on the number of errors made? Based on the scatter plot. Based on the scatter plot. The more time you spend rectifying the errors, the fewer mistakes. Let me explain why. Check this point. 23 hours, 23 seconds taken. How many mistakes committed? Only 2 mistakes. Check this one. 15 seconds. How many mistakes? 7. Check this one. This one is how many? 14 seconds. How many mistakes? 7. 13 seconds here. How many? 8. So what does that mean? It shows that it's an indirect relationship in a way. As one variable increases, the other one decreases. The more time you spend on errors, the lesser the errors. More time you spend working out mistakes, then the lesser the errors. But if you spend little time, there'll be more mistakes. This is the relationship that we came across. Because you can see here, lots and lots of time was taken. 23 seconds. How many? 2. Check this one. 9 seconds. Time is little here. But check the number of mistakes. 9. As compared to 2 that were taken by a learner who took 23 seconds. So there is that indirect one. As the one variable increases, the other one decreases. That's how we answer this question. What is the influence of more time taken to complete the task on the number of errors? As the more time you spend on errors, the lesser the errors. The next question, determine the equation of the least squares regression line. Least squares regression line. Teachers, please revise this with your learners. Grade 12 learners, do not enter the exam room if you're not sure. Make sure that when you enter the exam room, you know how to determine the equation of the regression line. Remember, the regression line is y is equals to a plus bx. That is the regression line. So, if the question determine the equation of the least squares of the regression line, we need to determine the value of a and the value of b. Our task is to determine the value of a and then the value of b. And there is an easier method. Let's just use the calculator. With the aid of a calculator, it's easier. How do we do that? Thank you. Take out a calculator. Thank you. Mode, make sure that it's on. Once it's on, and then you press mode. You've got those three options. You go 2 for statistics. Then you've got all those options that are available. As you can see, option number 2 is a plus bx. A plus bx is the regression line. Therefore, it's number 2. You press 2. Now you've got a table. And in this table, we have to enter those set of data. Let me enter 23, 21, 19, all of them. If I enter 23, 21, 19, 9, 15, 22, 17, 14, 21, 18. I've entered the first row. Now I'm going to enter the y values. It's 2, 4, 5, 9, 7, 3, 7, 8, 3, and 5. Now I've entered everything. Now that it's entered, you go to AC and then go to Shift 1, Statistics. Then lots and lots of options will be given. But what you want here is the regression line. Check option number 5 according to my calculator. Regression line is number 5. It depends on the calculator. In other calculators, you find the regression line is line number 7. Differs from one calculator to another. So according to this calculator I'm using right now, the regression line is 5. Then I enter 5. What am I looking for? A. Remember, we want the value of A. Then A is 1. Then your equality sign. Then it's 14.71. It means A is equals to 14.71. Now that we have determined the value of A as 14.71, as indicated in the calculator, 14.705, correct 2 decimal places, 14.71. Now let's determine the value of B. Shift 1 again. Regression line is number 5. B, see, B is number 2. Then you press 2. Then say equals to. Then it means B is equals to negative 0.53. Let's enter negative 0.53. Now you've got the value of A and the value of B. So the least regression line, the equation becomes Y with a capi on top is equals to, what is the value of A? 14.71 minus 0.53x. This is the equation of the least regression line. The question says determine the equation of the least squares regression line. So this is the equation if we are answering 1.3. Just about to finish. Time is up. The next question, 1.4 states, calculate the correlation coefficient. Remember, you still have the data in your information. The correlation coefficient, all you have to do, Shift 1. Let's go to regression line. You've got those options. Regression line is still number 5. And then correlation coefficient, which is R. R in this case is number 3, which is equals to check R. Our R in this case, according to the calculator of mine, it's negative 0.96. R is equal to negative 0.96. That's how we answer 1.4, correlation coefficient. Then after determining the correlation coefficient, predict the number of errors that will be made by a learner who takes 13 seconds to complete this task. 1.5. The learner takes 13 seconds. Remember the equation, y is equal to 14.7y minus 0.53x. Remember x in this case, errors, time taken in seconds. So you've got 8. Because if you read through predict the number of errors that will be made by a learner who takes 13 seconds. The learner takes 13 x here. This is the x values. These are the x values. These are the y values. So it means x is equal to 13. What do? Come to the equation. 14.7y minus 0.53. We substitute x by 13. And then we can work it out the answer. Let's check. Then the answer will then be 14.71 minus 0.53 multiplied by 13. Let's check the answer then. The answer will then be 7.82. 7.82 if we work it out. The last question. Comment on the strength of the relationship between the variables. Correlation coefficient 1.4. Calculate the correlation coefficient. Correlation coefficient indicates the strength of the relationship. R is negative, so the relationship is indirect. I'll show you the table, and learners, you must know this table by heart. Because that is the table that we use for description. Check. Quickly, know that table by heart. If you've got -1, perfect negative association. Negative 0.9, strong negative association. Negative 0.5, moderate negative association. Negative 0.2, weak negative association. Every CAPS compliant textbook has got this information. So this is the correlation coefficient. This is the value of R, and this is how you interpret it. If it's 1, perfect positive association. So already in our case, our R was, let me say, negative 0.96. So already you talk of negative association. It's negative. But because it's 0.9, it's a strong negative association. It's a strong negative association. So when answering this question here, we say comment on the strength. We said it's a strong negative association. Why do we say strong? Because remember, our R is negative 0.96. It's a strong negative. It is not perfect. Do not round off. Because if R is equal to -1, then we have a perfect negative association. But this one is negative 0.96. We do not round off. Please avoid rounding off. The answer is R is equal to negative 0.96. As a result, the nature of the association will then be strong negative association. If it was -1, we would say it's a perfect negative association. I hope it's clear, and I hope you have seen the table. I've come to the end of the presentation. I hope, to a certain extent, the presentation will add value, and I also believe that you'll also be a bit inspired, and you will work even more harder. Grade 12, from the bottom of my heart, I wish you all the best in this coming examination. And you are going to see me more often, especially when coming to this revision program for the end of the year exam. Please focus on the studies. This is the time to focus on your books. Ask your teachers where you don't understand. I wish you all the best. May God bless you. Thank you.